Yeah, hello everyone. Can you hear me?
Yes.
Yes, sir.
Okay. So I have also shared the YouTube stream link. So in case you want to see my video as well, there's some problems with recording and with OBS and switching on the video in Google Meet. So there's this YouTube link as well. In that case, there also this exact stream is we are having the stream there. It's there also. If you want the video as well, it's available on YouTube. And I've also shared the materials link. Whatever we do in the tutorial today, it will be available on this drive folder. So
Okay.
so if anyone can confirm that the YouTube link is there's proper sound and all, so it will be a bit helpful. Then we can start. Is it okay?
Sir, can you please resend the YouTube link?
Sure. This is the YouTube link and this is the Google Drive link. So once someone confirms that it's working, so we can start. Yeah. Is it working? So
Yes, sir.
yeah, the audio is clear, right?
Yes, sir.
Great. So everything is okay, and the video also is there available.
Yes, sir.
Okay. So let's go ahead. So this in this course we'll be doing the course name is Basic Calculus 1, and I'll be your TA1 who would be taking live sessions every Friday from 6 to 8. So this session is fixed. So whoever is joining, I would recommend you need not join all the sessions because people would be covering the same things again and again. So you can join in one of these sessions and according to your schedule and all, you can choose an appropriate one of the three links that you have been shared about the three sessions that will be organized. One is today, one is on Tuesday. I'm not aware of the third one. Uh, yeah, you can. This is the Basic Calculus 1 session. So any videos, anything related to that would be useful. So uh, Abhinav. So this is whoever is attending this course would this would be relevant to them. We'll be solving questions and we'll be revisiting concepts that have been done in the course. So does that answer your question? And Shanghamitra, any question before you go on with the questions? I'll introduce myself. I am Moinak Vishwas. I am a student of IIC Bangalore. I'm a PhD student at IIC, working in Brain and AI. So I would be doing this session every Friday, and that's about myself. Anyone else? Shanghamitra has a raised hand. You can go ahead and ask. So if you have a raised hand, you're not unmuted. So yeah, you can go ahead and ask your question. I don't understand. You have two people raising your hand. Shanghamitra can ask her question, then RK Gupta can ask his question. Okay, it seems that Shanghamitra is not here. So RK, so you have so many raised hands. So is there an issue? One of you can unmute and speak up. I can't hear any of you.
Sir,
Yeah.
So in this session, we'll be covering the questions only, or there will be some short summary for the course.
We'll be having I'll be covering I'll be trying to give a holistic picture in this session. So you will not only do questions, we'll be having short revisit to the concept that are being taught in that week. Does that answer your question?
Yes, thank you.
Anyone else? Tonushri Mehra?
Yes, I asked the question.
Yeah, okay. So anyone else? Okay. So just as yeah. So my screen is visible. So will be, if there are no more logistic issues, you can lower your hand, and if you want, you can switch off your videos as well. So otherwise, you would be your video may be available on YouTube. So in that case, you may want to switch your videos off since you're recording this session. So if it's not mandatory to keep your video on. So some of you have your video on. So in that case, you can switch it off if you do not want it to be on YouTube. So okay. So today we'll be discussing mainly functions. We would be building up to introducing calculus over the next few weeks, but before that we would be discussing functions, and I'll be trying to cover as much as possible in this session. So it would be mainly how to plot, basic plotting of graphs, how to transform graphs, to composition of functions, inverse, domains, and range of functions. So before we do that, so we would assume the real number line mostly throughout the sessions in the or in the course as well. So here I have drawn a number line. So as you all know, the first numbers are the natural numbers that are positive integers. So I should not define numbers by one to the other. So this is the set of natural numbers 1 through infinity. So then you have the set of whole numbers, which is natural numbers union 0. You have integers, which is minus infinity, minus 1, 0, infinity. You also have rational numbers defined by p by q, where p comma q belongs to integers and q is not equal to 0. And between any two rational numbers, there are infinite number of irrational numbers that's defined by p. These are irrational numbers. For example, root over 3, pi, e, etc. And the real number line is defined by q union p. So this is the setting. We are not going to formalize, going into large theoretical details about number theory, but this is the amount of information that you need. So the real number line does not have any gap to be. That would be enough. This definition would be important to understand. For example, if you have a number x that belongs to real number line, so for any epsilon, x minus epsilon to x plus epsilon, you have infinite number of real numbers. For any epsilon that is not equal to 0. For any epsilon, for all epsilon not equal to 0, this is true. So you would have infinite number of real numbers. So this is how you understand how the real number space is complete. So you don't have any gaps. So this is what you'll be using throughout. So yeah, go ahead. If anyone has a question, you can ask, or we can go ahead with. I don't think there is much to ask here, but we can questions can come in after we have learned a few things. So anyway, so I'll start off with absolute value functions. So what does an absolute value function? We'll be using this function throughout, so it's good to define. So it's you can see it's less than 0. In case of less than 0, it's minus x, and when it is greater than 0, it's x. So what does that mean? So if I plot this graph, so this is x. If it is this, these are values of x, and this is mod x, or the absolute value of x. So this is nothing but your y equal to x line when x is greater than 0. So if anyone has any problem with understanding plots, you can stop and ask me. So now for x less than 0, you have y equal to minus x, and that is this line. So this is how you define absolute value function. So I see a raised hand, I guess. Gokul, I saw. So okay. So this is how you define an absolute value function. So given a value, so what it does, this is more of a theoretical standpoint. So given any number, it returns a positive number, positive part of the number. For example, if you give minus 5, you pass through the absolute value function, you would get 5. That's all. You would get, if you pass 5 through it, you add 5 only. So because for less than 5, for less than 0, you would have minus of minus 5, that would be 5. So if anyone has any doubt with absolute value functions, you can ask.
So
Yeah.
So I had a doubt in the previous one. What was epsilon?
Epsilon is any number, any real number that is not equal to 0.
Okay.
So we would formalize the use of epsilon throughout the course, but now for now it's any real number. For not equal to 0 belongs to any real number. So you would have infinite number of real numbers in between them. That's what.
Okay.
Yeah. So these are all, you would have much formal definitions in number theory, but since it's a calculus class, we would not go into that. So now let's try and solve a question regarding this. It would clear a lot of doubts regarding absolute value functions. So you're told to solve this inequality, which is 2x plus 1 greater than equal to 5. So for what values of x does this hold? For what values of x does it hold? So do you have any idea how should we proceed? If anyone has an idea to present, you can. So I'll give you I'll wait for a couple of seconds before I start solving it. Okay, so what have we? So Prathi, if I'm Prarthi, yeah, Prarthi, go ahead.
Yeah, so like the way we have defined mod x, the same way we can define 2x plus 1.
Correct.
So we can put 2x plus 1 mod equals
Yeah.
minus of
Correct.
2x plus 1 for 2x plus 1 less than 0, and positive 2x plus 1 for 2x plus 1 greater than or equal to 0.
That's great. Thank you. So these are the two conditions that would come up. If you have lack of space, we'll go to the balance. So anyway, so this comes up with the condition x is less than equal to minus half, right? And this comes up with the condition x is greater than equal to minus half. So for if x is less than minus half, so in that case you would have minus 2x minus 1, right? So let's try and solve it. So case 1 would be, so let's take this as the case 1 and this as case 2. So in case 1, minus of 2x, so as Prarthi pointed out, so minus of 2x plus 1 is greater than equal to 5 would be the solution. So, and then we can solve for it. So you will get x is greater than equal to or if we take it to the other side, so let me write it, let me skip a step for the lack of space. So it will be 2x less than minus 6, and which means x would be less than equal to minus 3, right? So minus any number less than minus 3 would yield the first case. So I would come up to how to, now can you tell me, so what are the two conditions? So here you have two conditions where x is less than minus half. You have written that as minus of 2x minus 1. So now how do you combine these two conditions to get the region in which this inequality is satisfied? So for this, it will be nothing but x would be, it's nothing but the intersection of these two conditions, right? 1 and 2. X belongs to minus infinity. So the way I'm writing this means, I'll explain in a while, union, or sorry for that, minus 3. So that's the thing. What does it mean? So for all numbers, this first bracket means an open interval. Since infinity it cannot be closed, so we always write an open interval at infinity, and this means at minus half a closed interval, means minus half is included in this set. So it's all numbers from minus infinity to minus half included, and this is all numbers from minus infinity to minus 3 included. If it was minus infinity to minus 3, so it would have been, this would have been an open interval. This is how you define an open interval, and this is how you define a closed interval. So you put a full dot, and you put a open dot, open circle, and a filled circle to define open and closed interval respectively. So this is nothing but x belongs to minus infinity to minus 3, right? So minus 3 is, yeah, Avinav, go ahead.
So what does that icon mean? That is the opposite of union.
Intersection. So the numbers are both in both sets. So for which numbers are present in both minus infinity to minus half and minus infinity to plus minus 3. So what are the numbers? Abhinav, can you help us out?
Sir, it's minus 3 to minus half.
Is it? It's the intersection of all numbers from minus infinity. So it's, let me draw that. So it's from minus infinity. One set is minus infinity to minus half, right? Another set is minus infinity to minus 3. So what, this is the intersection, right?
Okay, so minus infinity to minus 3 is the intersection.
Yeah. So in case you have some problems, you can always in your rough draw the sketch of the number line. So that's why we started off with the number line. Yeah, so Vinod, you can you will get the video on YouTube. So I have shared the link. So I sometimes, what the NPTEL team does is that they fail to share the videos. So I generally share my YouTube video link here itself. So I'll just share it again. So that is the link, you will get the video in. So you can visit my channel and you can whatever you subscribe, whatever you do. I don't want to promote it, and whenever there's a video, you will get the video regarding this course. Will be all the course details will be put up at that YouTube channel according to NPTEL. This is all the guidelines that have been given to us. So anyways, so this is case 1. Similarly for case 2, where x is greater than minus half. So in this case, you have 2x plus 1 greater than equal to 5. So now x is greater than or equal to 4 by 2, which is nothing but 2. So what is the intersection of these two sets now? X is between minus half and x is greater than minus half and x is greater than 2. What is the intersection of this set? Anyone?
So minus half to infinity.
This is not right. So someone else was
Greater than or equal to 2.
right. So this is between minus half to infinity, right? And this is between 2 and infinity. So what is the intersection of these two sets? So since you're taking this as the condition and then solving, and you're getting another inequality, so it has to be the intersection of those both those inequalities. So in that case, it's from 2 to infinity. So this is x belongs to 2 to infinity. So what should be the final answer for this? So for both these cases, case 1 and case 2, if you combine, it becomes minus infinity to minus 3 union 2 to infinity, right? So in these two ranges, you would have this satisfied. So let us write it down here and then do a back calculation and see if it is really true. I'll also show a way to validate your answers. So using an application. So you put any number less than minus 3, right? So you'll get this as lesser than minus 5, and you put a mod that becomes greater than 5. Similarly, you put 2 here, you get 5. So if you put 3, you will get 7 and so on. So that is always greater than 5. So just to validate, I have an app that you can use. It's known as Desmos. So you can use this way. So what is this? What is the solution? So it's mod of 2x plus 1, and I close the mod, greater than or equal to 5. So you see all numbers between minus infinity and minus 3 and 2 to infinity. So it's matching our answers, right?
Yes, sir.
Yes. So this is the way you can also check your answers. You will be plotting a lot of graphs in this course, so you will be also able to, this app would be helpful. So now that was the warm up to our course. So this is a typical more absolute value problem. If you have any doubt, you can stop me here, or we would start with functions, which is the major part of today's session.
Sir, I have a doubt.
Yeah.
Sir, in both the cases, you take intersection. So how do we know that at what point we need to take intersection and what point we need to take union?
Correct. So I told this once. So you have two cases, right? So you get a solution from case 1 and solution from case 2. Both are valid solutions, right?
Yes.
So you would take the union of those two cases. Whenever you divide a solution into disjoint cases, you take a union of those. So disjoint cases, you take a union, right? And don't call me sir, okay, please. I am Moina. You can call me by your name. That's enough. So disjoint case, you take a union, and intersection happens when you have already assumed x to be less than half, right? So for all x less than half, this equation holds, right?
Yes.
Not for x greater than half. Does it hold for x greater than or equal to half?
No, less than or equal to half.
Correct. So it doesn't hold for that. So in that case, what do? So it holds for x less than or equal to half, and it also holds for x less than 3. So both these conditions must be satisfied, right?
Okay.
So if both conditions are satisfied, condition A and condition B, so you take an intersection of those two conditions, right?
Okay.
For example, I'll draw a Venn diagram. So say x belongs to this set A and set B. So x belongs to A and x belongs to B. This is told in the sentence. So where would it lie?
In A intersection B.
Yes, that's why we are taking an intersection.
Okay.
So this was the solution. So so function definition. So this I have given a formal set theory definition here. You can go about it. reading it, so it will be available. So I've told that a function is a mapping from a domain to codomain. Mapping from domain to codomain defined as a subset of a Cartesian product. So you know what is a Cartesian product? It is defined by a number taken from first set and a number taken from the second set, an object to be exact. So in set theory you don't necessarily need numbers. So you take an object from set A and an object from set B and you form an ordered pair. So AB and BA is different. So remember that AB is not equal to BA. So in that case, for every A there is a B such that f of A is B. And if A comma B and A comma B prime belong to F, B is equal to B prime. I know it sounds Hebrew now, so I wanted to read out the definition first. But let us slowly take into account what this means. So let us take how to parse mathematical syntaxes. So what are the few points? So I'll go to a fresh place and let us write it down there. So yeah. So the thing is, what did I write? So F is a subset of A cross B. Okay. And for every A comma B belonging to F, you have A belongs to A and B belongs to B. This is what we wrote. And for all A belongs to A, there exists a B such that f of A equal to B. So what does this mean? So this is the first condition. So first tell me what does A cross B mean? So is there anyone who does not know what is A cross B? A Cartesian product? So then I'll explain. So for example, so if no one, whenever I ask, if you do not know, if a single person does not know, I'll explain it. So you can just raise your hand even if you don't want to. Yeah, so you do not know, so we'll do it. So A, for example, A.
Yes, sir, please explain it.
Yeah.
A cross B.
So A cross B would be an ordered set, so that you take the first element from set A, for example, 1, and the second element from set B, that is A. First element from set A, second element, say again, all possible combinations, right? So 1 comma B. So 2 comma A and 2 comma B. So this is a Cartesian product. So is that okay?
Yes, sir.
So you take all possible combinations. So with A1 you take these two, with 2 you take these two. So of these combinations, if you select a subset, that is defined as a function. And what conditions must it hold? It must hold, the first condition is, for set A, all these elements must be there in F. So for all A, so if I draw a set diagram, so you say 1, 2, 3, right? You have 3 elements in this set. So let us draw 4. So for all these, so f of 1 must have a value in B. So this is the A set, this is the B set. This is known as the domain set, and this is known as the codomain set. Go ahead. Okay. You see, so for A, say you have, yeah, Gautam, go ahead.
Hello, sir.
Yeah.
Sir, is there any geometrical understanding for Cartesian products?
That's what I've written, right? So Cartesian, if you have the real number line, you have R here, right? And you have all R in the y-axis. That's a Cartesian product.
Okay.
So you have one axis, you have the other axis. So every x comma y in the xy plane would belong to R square, right? That is R cross R. That's the.
That means there is a one-dimensional object converted into two-dimensional object, no? A cross B.
Yes, so it's R cross R. So every element in the set A is associated with some element in set B. That's it.
Okay.
Actually, in Cartesian product, it will be with all elements. So it's an exhaustive cross product.
Okay.
But in functions, there is a thing. For example, what I told, for every a. So can someone tell me how the mapping will be? So for every a, so this is an a, this is an a, this is an a, this is an a, right? For these are all the a's in capital A set.
Yes.
These are all the elements of set A. So for every A, there is a mapping to set B, right?
Yes.
So this is f of 1. This is f of 1. Say f of 2. So this is f of 3. And say this is f of 4. So this is a valid mapping, right?
Yes.
Correct. But this is not enough for functions. For functions, there is another condition that must hold. That is, if a comma b prime belongs to the function, then b is equal to b prime. What does that mean? It looks Hebrew, but if you just think about it, so for example, I'll not disturb this figure. Let us draw another figure. No, let's draw another figure. So 1, 2, and let's consider the case that we had taken here. Right, so explain case 2. This is case 1 and this is case 2. These two conditions. This is 1 and 2. This is A and B. Now someone tell me, is this a valid function?
No, sir.
Yeah. So anyone else? Is this a valid function? See, here you have 1 comma, yes, right, it's not a valid function because 1 comma A and 1 comma B are both belonging to the function, right? This is the mapping from set A to B. So A is not equal to B. So this is not a valid function. So for any two elements in the codomain set, there cannot be a common. For any, what did I say? For any two elements in the codomain set, I'll write it down. For any, this is the graphical interpretation as many of you were asking. Any two elements in the codomain set, there cannot be one element in the domain set. Is this statement clear? For example, I'll draw a figure here. Is this a function? This is the first question. So this is f of x and this is x. And you have another function. This is also f of x and this is x. Is this a function?
First is not a function, I think, but
Okay.
second is a function.
This is a function, this is not a function. So can anyone tell me the reason behind it?
For 1x, there is a two.
For 1x. So we are considering a function from x to f of x, right? So say this is real number line. So real number line to real number line. These are the two sets, right? This is set A, this is set B. Correct?
Sir, it is not satisfying the 1-1 condition, I believe.
1-1 condition is satisfied. So I am taking, you cannot draw to infinity. So you can take 1-1 condition can always be satisfied. So it need not be RR. You can change your domain according to the function. So I'll tell you that. Wherever the function is valid, you can tell that is the domain of the function, right? Domain is implicit to the function. So any function you define has an implicit domain. You did not tell the domain. We'll come to that. So 1-1 you need not be very, very conscious about, right? So 1-2 is the thing that you need to be conscious about. So it's not a function because, see, for this x, there are two values of y, right? So for x, you have x, this is f of say x1 and say this is f of x2. So you're mapping f of x1 and f of x2. Is this a valid function? So from a single value of x, you're getting two numbers, right? this is not a valid function. Okay, is it okay?
Yes, sir.
And for this is a valid function, because for a single value of x you have only one f of x. But this is also known as many to one function. What does this mean? So for example, this one, both 1 and 2 map to the same value a, right? So here say -4 and 4 map to the same value. So in that case, it's a many to one function, right? So many, what does it mean? Many in domain to one in range. That is not, there is nothing wrong in that, right? You can have infinite number of points in a domain mapped to the same value. I'll give you an example for that. So is this reasoning clear? Why is the first one not a function and the second one a function?
Yes, sir. Clear.
Great. So you see, I'll give you an example where infinite number of points plot to the same function. For example, f of x is equal to 1. Is this a function? Can anyone tell me what will the plot look like?
A straight line passing through y equals 1.
Correct. So it's like this one, right? It's a straight line, so y equal to 1. So in this case it's a function, right? Because for a particular value of x you have only one f of x. So I say f of 3 is also equal to 1, f of 5 is also equal to 1, and f of x is also equal to 1 for all x in real number line, right? So but there is for one particular value of 3 you do not have two outputs. Does this give two output? It gives only one output, right?
Yes.
But as I told you, there can be ways in cases in which you have all the numbers pointing to a single value. So this is a very, very drastic case known as I'm just naming this all to one function, for example. So it's also a many to one function, right?
Yes, sir.
So all values in the real number line are pointing to 1. So I believe now with the graphical figure and all, you are able to understand what is a function. So it's a mapping from one set to the other, or specifically from the domain set to the codomain set, where every element in the codomain set will have every element in the domain set will have only one image in the codomain set. Is that okay?
Yes.
Yes. So multiple, you cannot have multiple elements in the codomain set having the same pre-image, but you can have multiple elements in the domain set having the same image. So we'll be using these terms image and pre-image very, very, very much. So image is a function mapping and in pre-image is the inverse mapping. This is pre-image. So anyway, so let's focus on, but this is also a valid equation. This is known as a relation, right? So we're not going into relation. This is very complex set theory, but whenever you have a single value mapping to multiple values, that is one to many function. That is not a function, just abuse of notation. That is known as a relation. When you have those cases, you can tell that it's a relation, not a function, right?
Yes, sir.
Yes. So relation would roughly mean it's any subset of the Cartesian product. So you can roughly, this is not actually true, but to bring an analogy to the case of functions, it's any subset of the Cartesian product is a relation. That's it. So now we'll be defining a couple of things before we go and solve questions. Yeah. So a few more things would be this one. What is a 1-1 function? So till now we have understood the mapping from mapping from set to set. Let's see what's a 1-1 function. 1-1 and many one we have already decided, like spoken about, right? So let's give an example. 1-1 is, this is a 1-1 function. This is a 1-1 function, right? Therefore 1-1 function means it's an injective function which means there is for all x belonging to, say, set A, f of x in B is unique. Is that all right? So is this the 1-1 function? So let me draw it with two colors. So the red one is a 1-1 function, but as soon as I put this, leave it. Yeah. So this is a 1-1 function, and this is a what is the second one? So I see people not responding as so much. So 1-1 and many to 1. You see many elements in the domain set. So you have 1 and 2 both pointing to A. So this is known as a many to 1 function.
Sir, actually, I am not getting. That's why I not responded. In the first figure, it is clear that it is 1 to 1.
Yes.
But in the second figure, I believe it is like 2 to 1. Many. Okay, it is there that 3 is connected to point C,
Yeah.
but 1 or 2 is connected to point A. So that is making me confused.
So that's why I'm saying a many to 1. So for f of 1 is also A, and f of 2 is also A, right?
Yes, sir.
So both A and 1 and 2 are pointing to the same image in the codomain set, right? So if
Okay. But sir, still it is not clear.
yeah, I understand. See, for the first one is clear, right?
Yes, sir. It is quite evident that for every function on domain, it is
every object in the domain set has a specific object in the codomain set which the function maps it to.
Yes, sir.
Function is nothing but a box. You feed a number and it spits out its value. It just assigns. So now, for if every value you put to the machine, it gives a different output. That's a 1-1 function. Okay.
Yes, sir.
And for this analogy is also helpful because for one value of x you can only get one value of y. So that's the thing. But now if a machine, say you give 4 as an input and -4 as an input, the machine gives you the same answer. So it's many values in the domain set giving the same output in the codomain set, right?
Okay. Yes, sir.
So for many values you're getting the same output from the machine. That's it. So
that will be many to 1.
Yes, many to 1.
Oh.
1 to many is not possible, as we have told, because for a particular value of A there can be only one B. You can't have many B's for a particular value of A. Okay.
Okay, sir. Yes, sir.
Great. So now, why I drew these functions like this? This is known as injective. Why is it injective? Because you are giving one injection to each of the element. From there's one syringe, one needle connected to every element in the output set. So that is mapped to some pre-image, right? So that's why it's known as injective function. Now you have this is one classification, 1-1 and many 1. So how many elements in the domain are mapping to how many elements in the codomain? This is one classification. On the other hand, you have another classification. Do you have any restriction on the number of elements in the codomain set? You have only one restriction, right? That all the elements in the domain set must be mapped to some element in the codomain set, right? Yeah.
Yes, sir.
Go ahead, Tanushri.
No, sir, by mistakenly I pressed that.
Okay. So somebody was telling something. You can go ahead. Okay. So you see, there was only one condition that we mentioned, that every element here. So every element here must have a needle attached to it. Every element here. But necessarily, every element in the codomain set need not have a needle associated with it, right? Is that part clear?
Yes, sir.
Correct. So if every element, So this is where you have two demarcations. So if every element in the, for example, this is known as a onto function or a surjective function. Why? This is the codomain set, right?
Yes, sir.
So every element in the codomain set has a needle associated with it, one or more needles. So in the codomain set you do not have any restriction. In the domain set only you have restrictions. So this is known as a onto function, where every element in the codomain set is associated with some element in the domain set. Is that clear?
Yes, sir.
Every element, I'll write in English. You can see the mathematical definitions. I won't want to read them out. They can be boring. So every element in the codomain set has a element in the domain set. Now in case of into, why is it called into? These two functions, star and star, these are all into functions. Right? Can anyone tell me why? This is because all the elements of the codomain set are not in the values that the domain set is pointing to. So whatever elements you are pointing to, this is known as the range set. What is it known as? The range set. So here the codomain, please note, this is very important. Codomain is ABCD, right? But the range is, can anyone tell me what is the range?
ABC.
Correct. So the range is ABC. So to formally state a onto function, range is equal to codomain. And for into function, what will it be? Range is a subset or superset?
Subset.
Correct. Subset of the codomain set. Nice. So this is all about the theory of functions. So what we did, we introduced functions. For every point you're having a machine is there, you're giving objects to it, it's giving values associated with the object. Where one object can't have two values. You cannot give one element to the machine and expect two outputs. It will not do. On the other hand, we did a lot of classification about functions, saying that you can either have one functions where every element in the domain set maps to a unique element in the codomain set, or many to one function where multiple elements in the domain set can map to a same element in the codomain set. This is one way of categorizing functions. The other way is to tell whether it's into or onto. So here we introduce the concept of range of a set. So the range of a set is very important. The range of a set is a subset of the codomain set. This is the set of all those points such that some element in the domain set is mapping to it. Right? I'll repeat that sentence again. If you want to parse that, you can parse. So it's a set of all those points in the codomain set that has a pre-image in the domain set. I think you would be able to process that, right?
Yes, sir.
Correct. So let's do an example. So this is a lot of theory now. So let's do an example. So let's again plot some curves. So I'll be doing a lot of plotting today. So this will help you throughout your course. You will be just plotting functions and you'll be able to tell many of the answers. So let's do this plot. Yeah. So how do you plot x square minus x by? So I'll put the plot here. So it will be very easy once you do limits and all. But anyways, let's try a hand at it. It's not required to know limits to plot this curve. So f of x, what can we write it as? We can take x common, right? On both the numerator and the denominator. Right?
Yes, sir.
I want someone else also to maybe participate other than
Yes, sir.
Correct. So we have this is as x minus 1 by, yeah, x minus 2. So what happens is, now for what values of x is this true? Does this hold for x equal to 0?
No.
Yeah. So for x equal to 0, you're dividing by 0, it's not defined. 0 by 0 is not defined. So at 0, you have no solutions to this. Now, how will you plot this, if you tell me? What would be the... So you can see at x equal to 1, what would you have the value of this function to be?
0.
0, right. And as x goes to infinity, what would you have the value of the function?
1.
Correct. It would asymptote to 1 because 1 and 2 would be negligible, right? So you would have something like this. So if everyone agrees, we can proceed.
So can you please explain it once again?
Okay, maybe I'll draw the final figure here. To explain, there's not a lot of space there, so let's do it here. So x into x minus 1 by x into x plus 2, right?
Yes, sir.
This is your y. And you're told to plot this function in order to know if it is a 1-1 function, many-1 function, and so on. So if you are wanting to plot many-1, 1-1 function, plotting is the best option. So if you plot, you can draw a horizontal line to see if any. I'll come to that anyways. So how did you know this is a many-1 function, right? In case of a many-1 function, you can plot a horizontal line. If a horizontal line meets at multiple points, it's a many-to-1 function. If a vertical line meets at many points, it's not a function.
Yes, sir.
So this is this question some 3 or something, I don't remember. So what we do here is, say we have this equation here. So x will be cancelled. Y is nothing but x minus 1 by x plus 2 for all values of x not equal to 0, right? This is what
Yes.
this is what I told till now. Nothing more. So and at 1 we know it's 0, right? This much we know.
Yes.
Why now who was asking? I need you to tell me if it is fine. Y of 1 is 0, right?
Yes.
So now, and y of infinity is 1. Why do I claim that? You put infinity, say put a number c. It's c minus 1 by c plus 2, right? If c is very, 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 very large, you put a number, for example, 1 lakh. Here, 10 to the power 5 minus 1, or say put 10 to the power 8 minus 1 and 10 to the power 8 plus 2. And if anyone has a calculator, go ahead and see how much is it. So maybe I'll do it here only. If you do not get the intuition, this may help. So minus 1 divided by 1 0 0 0 0. Be careful with the number of zeros. Is it okay? 3 3, one more, right? Plus 2. So what are you seeing? What is it going to?
About to be 1,
Yes.
almost equal to 1.
Why? Because these
Almost equal to 1.
yes, these two numbers are negligible considered to very large numbers, right?
Yes.
So you can drop this off. So this will be somewhere up to 1. It can never go above 1 for positive infinity. So this much we are able to plot. Right?
Yes.
Good. So values of x less than 1, is it negative or positive? So I'll give you an example. You'll understand that. Say you have another point at, so whenever you have a polynomial or ratio of polynomials, what you do is you break it up like this. So the important points are, if you have like this, so what are the important points? 1 and minus 2. So how do you know the important points? You would equate x minus 1 to 0 and x plus 2 to 0, right?
Okay. Yes.
This becomes the important points for your curve. So once you do that, you get x equal to minus 2 and x equal to 1. Now you see x is equal to minus 2 as the important point and x equal to 1 is an important point. Let's do it for minus infinity as well, and then we'll see. So once we put y is minus infinity, it's the same thing, right? Minus infinity minus 1, minus infinity plus 2. This is abuse of notation. You can't write like this. We'll come to limits the next day. You'll understand. So it's minus 1, right?
Yes.
So it can add plus 1 again. Don't say yes by without looking. So both are negative on the numerator and the denominator. So it's positive, right?
Yes, sir. Yes.
Correct. This is 1. So I can put this asymptote. This is known as an asymptote, a line which a curve never meets but approaches infinitely. So it's somewhere at infinity, either this side or this side. That we'll have to figure out. Let's figure out. How will we figure out? By looking at the point at. Can anyone tell me which point is the important point we need to look at? We have
Minus 2 and 1.
minus 2. 1 we have already looked at, right?
Okay.
1 is 0, we have already looked at. So minus 2. So now you tell me x minus 1, x minus 2. So you have a number, say this is 2. I define a minus 2 and I define a number minus 2 plus. Very close to 2, almost 2, but little bit like shifted. Very small. So 10 to the power minus 31 you are adding to the number. Shifted to the right. And I define another number minus 2 minus. That is a bit left of minus 2. So what will happen? So numerator is minus 3, right? Always here. Both are minus, right?
Yes, yes.
Minus 2 minus 1 is minus 3. But the denominator, when I put minus 2 plus and minus 2, what is the value of the denominator? Is it a positive number or a negative number? Similarly, I put another number, minus 3 by minus 2 minus minus 0. Or rather, these are all plus. What is the denominator? In the first case and second case.
Same.
Is it same? So what is, I'll draw this number line again. So this is 2, right? Minus 2. This is minus 2 plus.
No, sir, it's not same.
Correct. I'll come to why it's not same. And you're adding 2 to it. So in which case is what? So if you add 2 to minus 2, you get 0. So but if you add 2 to minus 2 minus, where will you land up? 0 minus, right? A bit left of 0. Because you have subtracted a bit from 2. See the distance, you would be able to understand. This is why, and this will be 0 plus, right?
Okay.
It's very easy to visualize. How will you visualize? A number that is greater than 2, minus 2, and you are adding 2 to it. It means it will be greater than 0 once you add that, right?
Yes, sir.
So if you have doubt, I'll explain again. So this is 0 plus and this is 0
Zero.
minus. So this will be what? Anything divided by close number close to 0? 0?
Infinity.
Yes. So there is a Sanjeevani, there is a lot of echo on your side. Can you fix that? So this is minus infinity and this is plus infinity, right? Both are minus. This is also negative, this is also negative. So you get a negative infinity plus positive infinity. This is your negative infinity. Right?
Yes, sir.
Correct. Similarly, at x is equal to 0, you put x is equal to 0. Close to 0. At 0, it's not defined. At close to 0, this is minus half. You can see. If you put 0 in this equation, you get minus 1 by 2. You will see how to know if it is correct or wrong when we do limits. So this is something like this. At 2 positive, it goes to minus infinity. That's what we found out, right? And at 2 negative, there's a jump to positive infinity. So this is the curve of this function. Is this okay? Did you understand? So what are the typical things that you do? You find the important points. Here 1 and -2 are important points. Then you see how the function looks as infinity. And then these three things, if you see, would be able to solve the question. Is that all right?
It's a little bit.
Okay, I'll first, now let's forget about it and tell whether it's a 1-1 function or a many-one function, or onto into what function is it. Let's classify it using the two types of features. What is it? What function is it? If I define this function as R2, I'm defining this function as R. So what function is this? Someone has to tell me this. If you're given this graph, what function is it?
1, 1.
1, 1, right? How did you tell 1, 1? This is a very good observation. 1, 1. This is the first point about this function.
Because for any value of y, we have only 1x.
Correct. So any value of y, you have only 1x. So how do you check that graphically? You draw a horizontal line and see if there is multiple intersections. Are there any multiple intersections? Even x is equal to y equal to 1 does not intersect, right? Y equal to 1 also does not intersect with either points, right? Because they never touch those points. 1 will never be reached. It's always less than 1 and greater than 1. Can you give me a number that for this it will be 1? Because the numerator is smaller than the denominator. So it will never be 1. X minus 1 means the numerator is smaller. So anyways, so can anyone tell me a horizontal line that can cut at 2 points on this graph? Any horizontal line? So somebody told me there is, for every value of y there is only 1x. So how to see if for any value of y there are multiple x? You would just put a line through that y, right? Like this, and so on. There's still some issues with it.
So I'm not clear.
No. If you're given this graph, can you tell me why it's 1, 1? Somebody told me that for a particular value of y, there's only 1x, right?
Yes.
So you take this x, this y value. How many values of x does this y correspond to? So this value of y means this line. So every value on this line has this y equal to some, say, -3, right?
Yes.
So is there any other point on this line for which that is on the curve? On this line, is there any other point?
No.
What does that mean? So for this -3, there is only one at y is equal to -3. There is only one point on the graph, right?
Yes.
Correct. So if there is only one point on the graph, there can be only one x associated with it. Right? There is only one x. Is there any other x? There's no x anywhere.
Yes, sir. Yes, sir.
Now the second point, is it a onto function or is it an into function?
Into function.
Okay. Anyone else? Then I'll come to Prarthi. What is the reason? If anyone else agrees or disagrees. So okay, Prarthi, go ahead. Why do you think it's an into function?
Because for y equals 1, we don't have any value of x.
Very good.
So
That's it. So the domain set, the codomain set is, the range is r minus 1, right? 1 would never be reached. And you have all numbers other than that, right? You have positive infinity, you have negative infinities. That is the right explanation. So anyone else? Do you have a doubt why is the into function? So I see Hedvi also telling into, that's correct. So it's a 1-1 into function. So I'll just plot this and then come back to the plotting of this graph again. Let's keep it handy for you people to see when you are free. So this is something like this. This is your graph. This is one. So let us plot it. Let's see if we have plotted it correctly, and then we'll come back to the doubts. I see a couple of people are not yet okay with this. Yeah, just a second. Yeah. So what is the function we are plotting? F of x is equal to x minus 1 into x by x into x plus 2. Now see. Do you see? Is this matching with our function that we drew? See? It's going to 1, right? On both sides. This is your 1. And this function is approaching your 1 throughout, right? Can you see that?
Yes, sir.
So this is, you need not, every time you do this, you do not need a graph, if you can understand, because in exams and in real, all graphs, generally people will use graph, but if you doing it manually, you would have a lot more insights on using various calculus tools. So the calculus tools were built to visualize graphs and plots. So what are the steps? We'll come to that again. So let's see once more. So, and we'll do a question related to this and then we'll go. For example, we had x into x minus 1. Let's leave out x for the timing since they are cancelling for all values not equal to x. So let's see which parts of the function are positive, which part the function is negative. So what are the important points again?
1 and minus 2.
Correct. 1 and minus 2. So all values of 1, all values of the function, this is known as a polarity curve. So this is not the shape of the curve, but it tells you in which side the function is positive or negative. So this side is positive and this side is negative. So tell me, for any values greater than 1, is the function positive or negative? For any value greater than 1, is the function positive or negative?
Positive.
Yes, Sanjeevani tells me positive. Anyone else? Only three people. Yeah, Shrishti also. I want some new people as well coming up. Yeah, so it's positive. So what happens is, what is the power of this? It's the odd power, right? So the trick is, whenever you have an odd power, you change sign. Right? Here at minus 2 also you will change sign. So you see between 1 and minus 2, the function really had negative values, right? and between these two it always have positive value, right? You can also check. So any number between -1 and -2, this is negative and this is positive. So f of x is negative. Similarly, if it is less than -2, both becomes numerator and denominator becomes your positive number or negative number. So in turn, f of x becomes positive. Did you get it? So let's do another question, you'll understand. And the plot, I think Tanushri had a doubt in the plot. You can ask which part of the plot were you confused with?
So when you started to put values other than -2 and 1, I got.
Okay, so what are the values that I put? So I put -infinity, -2, 1, 0 and infinity. So these 3 points you generally put in a graph. You put values on the function and see where they are. And then you put the important points.
So your voice is breaking in between.
Okay. Is it the case for everyone? I think that can be due to some internet issues. Is it happening for a long time or just
It started just now.
now? Okay, I see. Is it okay now?
Yes, sir.
Okay, that it's some Wi-Fi issue, I guess. Anyways, if this happens, you can stop me. So whenever you have negative points, you have important points. So my trick is important points plus -infinity, 0 and infinity, right? These three you need to plot. Then you will have a rough idea, rough estimate where the function would go to or how it looks like.
Oh,
So I put infinity, I got 1, right?
yes.
I put 0, I put 1, I got 0. And then I put values very close to 2. So 2, I see a number, whenever the number is in the denominator. So you have a problem of 0 division by 0, right?
Yes.
The function can blow up. So for that, for any number very close to denominator, this is also called the poles of the function. Poles meaning the points at which the function can blow up. That's why it's called the poles. So at -2, you see it's not defined. So very small values close to -2 on both sides, you see. If it is right side of -2, you add 2, it goes to a positive range. So you divide by that and you get a positive number, right? You get a positive number. That is anything towards the right of it. Anything towards the left of that, you get a negative number, right? So my 2 minus plus 2. So I drew this thing.
Yes.
So if I have 2 here, I have 2 plus here. This is very important. You'll have to understand this to understand limits in the next session. So if it is 2 plus and here is 0, and if I add 2 to it, so what will happen? Will you cross 0 or will you be left behind 0?
-1 or the +1?
If I add 2 to this number, this -2 plus, if I add 2 to this, will you cross 0 or will you be left behind 0?
Cross 0.
Correct. So this becomes positive, right? That's my point. So, and if you are having, this is why you need to plot the number line and see. Once you are doing that, after a couple of practice and all, couple of hours of practice, you would be doing it in your head. That's not a problem. So some number less than -2, if you add 2 to it, you would not cross 2, right?
Yes.
That's what I said. That's all. So if you do not cross 2, you will end up with a negative number. So in this case, if you have a negative number, the numerator is also negative, the denominator is also negative. You have positive infinity, right? Negative is positive.
Yes.
So you end up with a positive infinity. Similarly, on the other side, you end up with a negative infinity. Or you can always plot this polarity curves to see whether the number is positive or negative. So this is another trick I told you. We'll use this trick to solve another question. I thought I will do it at the end of the session today. I don't think I will be able to do all of these. Whatever is remaining you can all do it as a exercise, and in case you have doubt, what you can do is you can comment on the chat or something like that. Let's see, we'll try to complete as much as you can. Let's do this. Let's draw the polarity curve of this function. So if you really have understood, I would request you to come up with the points this is the polarity curve I will draw. So what is it told? You are told to find solutions for this such that it is less than 0, right? This function is less than 0. You are told to find that. So what are the important points in this function? Where the function actually goes to 0 or vanishes or goes to a pole. What are those points? So what are the important points?
So is it 3, -5?
What are the zeros? Go ahead. Zeros are?
+3, -5, +7.
Correct. And what are the poles?
Is it +6?
Yes. And?
+4.
Correct. So at poles your functions are not defined. That is a very important thing you must be able to understand now, right? Because anything divided by 0 does not hold. So your important points include zeros union poles. So which is the smallest number here? -5. Then you have 0. I will not, just to keep a track of 0. Let's keep 0 here. 3. This is not to scale. Be aware of that. Then you have 4. You have 6. And you have 7. Does that make sense?
Yes, sir.
Okay. So what do we do now? So any number greater than 7, is it positive or negative? This is very simple. You can go ahead. It's the largest number. Correct. The right end will always be positive, right? It's the greatest number. So it's positive. At 7, will there be a sign change?
No, sir.
Why? I told there will always be a sign change, right? When you have odd power. Yeah, you'll always have a sign. Why will it happen? So this is a positive number, right? Now presently it's positive up to 7, where it becomes 0. Now this number becomes negative, right?
Okay.
So any number less than 7, -7 would be a negative number, right? For example, 6 minus 7 is -1, 5.5 minus 7, 6.5 minus 7, 6.99999 minus 7, everything is negative.
Yes.
So the trick is to odd powers, polarity change. Even powers, will it change? This is same as x minus 4 square. So why? I'll come to that. It will not change, Helvi says. So I would like you all to, if you're comfortable enough, you can chat with me as well. You can speak up without, instead of writing on the chat. Anyways, the odd, so it changes polarity. Now at 6, it is an odd power, right? So you get another negative number. So it goes to positive again, right?
Yes, sir.
Now comes the question. At 4 and 6, these are open points. You would agree, right? These points, the function is not defined.
Yes.
These are poles. So now at 4, will the polarity remain same in both these two cases, or will the polarity change?
It will change.
Will it? Is x minus 4
As in, no, it will remain this.
X minus 4 is always positive, right? for change in polarity, Prarthi, you need a negative number.
Yeah, as in I meant it will remain
Yeah,
positive.
I understand. No, it's not, there's nothing to be ashamed of. You can always, I'm also learning. I can make mistakes anytime. It's maybe a slip of tongue and so on. So the idea is, for getting a negative number, for change in polarity, the idea is, if anyone disagrees, please come up. So if x comma y, so x comma 2, and you have a change in polarity is less than 0. What does it mean? X is less than 0, right? Similarly, minus 2x is greater than 0. What does it mean? X is less than 0, right? This is what it means. So for any time when we have change in polarity, we need a negative number to change polarity. Positive numbers can't do anything when you're multiplying it to other numbers. So you multiply negative with a positive, it remains negative. You multiply a positive with a positive, it remains positive. But anytime you multiply a negative number with a positive number, you get a negative number. You multiply a negative number with a negative number, you get a positive number. Every time you multiply, your sign will change. I hope you get that. Everyone else? So both these two numbers in even powers, you have always positive numbers coming up. So that's the reason why you would have this thing where you have a no change in polarity. So both these two cases, you would go from here all the way to 3, where you will have a change in polarity. Do you agree?
Yes, sir.
And again at minus 5, you will have a polarity change. So what is the answer? What is the region in which this is what to say? This function is negative or positive? Let's see. Go ahead. It's between minus 5 to 3. Right? Minus 5 is a pole, so you include this. 3 is also a pole, you include this. Union. These two are negative, right?
Yes.
And between 6 and 7. And 6 is not included. Get that right? 6 is not included because, very
6
good.
is pole.
Yes, 6 is a pole. Very nice. So I hope I'm able to convey this thing about ratio of polynomials or polynomials in general. I see Hedvi always giving the answers, but I would like you to also discuss with us. So should I do this first or should I do this first? Which is more important? Okay, let's do the problem of domain first and then we'll go to plotting and all, because this is, since we did this just now, domain and range we are discussing, so let's do this. So you have a function f. Oh, I need to define composition of functions. Anyways, so we'll go ahead with the plan. So let us plot some graphs. So I have some plots ready for you. For example, y is some even powers, you would have a positive plot, right? Like this, you have a U-shaped plot. Any odd power, you would have a change in sign. So this is also following your say x to the power 2n. If you do the polarity curve, 0 is a point, right? 0 is a solution to this curve, right? So you would only have positive numbers. People who were answering and everyone else, so did you understand? At 0, which is the important point at x to the power n? Which is the 0 of this polynomial? 0 is a 0 of this polynomial.
Yes.
So, and it's a even power, so there is no polarity change. Similarly, here you will have a polarity change.
Yes.
Correct. And for odd functions, so this is how square root of x is defined. Y equal to square root of x. Why? We'll see that in a while. I've also plotted sin x and cos x for you. We'll do it anyways later today and also next day. But anyways, these are good to keep in mind. This will be very useful. Let's do a couple of plotting, you'll understand. So this is how I'll try to demonstrate how to transform graphs, right? So let's see. So f of x, say I define this as x to the power 4 by 5. I define this f of x to be this. So how will this look? Can anyone tell me? From this graph you should be able to tell how will it look. So step 1, you'll need to develop a series of composition of functions in order to draw a curve. So how will I do it? First, let's take a very simple case. So this is the case that I'm taking. So instead of taking x minus 2, I'm going to take the entire x minus 2, consider it as x. Right? So x to the power 4 by 5. So does this curve, what does this mean? Y is equal to root 5 x to the power 4. Does this accept both negative and positive numbers of x? This is this curve, right? Any odd power. So this is x to the power of 1 by 5. It's an odd power. So for example, I'll give you an example. Minus 27. What is the cube root of minus 27? Minus 3 into minus 3 into minus 3, right?
Yes.
So it's minus 3. For odd powers, you have valid square negative numbers within the root. But for even powers, you don't have valid negative numbers, right? You can never multiply. You need a imaginary part for that.
Okay.
So can you put two negative numbers together and make a negative number? You can't do that, right? That's the idea.
Okay.
So in this case, x can be any number from minus infinity to infinity. So it will look like this. So it's good to have these curves in mind, right? So let's define this 1 by 5 only. So this will be, first step would be something like this. Okay?
Yes.
Next step, I'm doing an even power to it. So even power to it means what? You will have a reflection over the x-axis. Why? I will come to that now. So you will have something like this. So for example, if I do something like this, minus 3 to the power minus 27 to the power of 1 by 3 whole to the power of 4. What is the answer? So it's first I do this, I get minus 3 to the power 4. That is minus 27 into 3 minus 3, that is 81, positive, right? So any negative number raised to even power is always positive.
Okay.
So uploaded videos, at the end of the class, I'll also again share the YouTube link. You will get the YouTube link. You can see the channel. You can subscribe to keep, at least for the session, during this course of this 12 sessions, you keep it subscribed to, you will be getting all the things and all. So, and then you can unsubscribe once the session is done. So it will be useful. So it will be reflection over the x-axis. So all negative numbers will be plotted to a positive number. So reflection over x-axis. Step 3. What do I do now? Now I transform this, I recenter it. This is called recentering. Where I say f of x minus 2. So if I write a function f of x minus 2, what will happen? What will be the new 0 of the function? What will be the new f of 0?
2.
Correct. So whenever you have f of x minus something or f of x plus something, your center gets recentered. That's all. There's nothing to it. So you have recentering here when x minus something happens. Similarly, if you have y minus something, your y coordinate would be recentered. So this will be something like this. right? This
Yes,
is
sir.
step 1, this is step 2, and finally I add 5 to this. What will happen? So I see people understanding. Tell me what will happen. If I add 5, what will happen? Try to find out yourself.
First diagram will shift.
Upwards or downwards or left or right? Where? This one will shift, right? This is f of x minus 2 plus 5. Where will it shift? Upwards or downwards? Leftwards, rightwards, where? So for example, if a function is at 0, it's 0. If I add f of x plus 5 at 0 value, what will it become? At 0 it is 0. If I add 5, so at 0 it will become 5, right?
Yes, sir.
So
Upwards.
it will shift upwards. This is the graph. So you see, I'll plot it here. You'll be able to relate. So how will I plot it? I'll plot f of x just as we did is equal to x to the power of 1 by 5. See, it's matching to our graph.
Yes.
So now I write y is equal to f of x to the power 4, right? It's matching again what we plotted. Next transformation would be, let us write this as, it's okay. Let's write z as y minus 2. So this is, I think this won't work, so we need to put a functional form to it. F of x, so let's see, g of x is this. Say h of x is g of x minus 2. Matching, right?
Yes, sir.
Next I shift L of x to be h of x plus
Yes.
5. So matched. This is how you transform. These are the steps you need to follow every time. So I'll write it freshly in a fresh format. Before doing that, I'll just, so here we have seen reflection and recentering, right? Reflection and recentering. This is also, adding 5 means recentering about y, right? So this is nothing but y is equal to, this is nothing but y minus 2 comma 5. This is also a way to see. Did you understand?
Yes, sir.
This is your new y tilde, this is your new x tilde. If you draw a new Cartesian coordinate system, the coordinate system has changed. From 0, 0, the new origin is 2 comma 5. Good. Now let's see how to tackle reflection about x-axis. So we have seen the curve of mod x, right? This is something like this. So we reflected the y equal to x curve along the x-axis because we took the negative value and made it positive. Now what do I do with mod y is equal to x? First, how do I plot it, and is this a function? So for all values, this is true, right? Say x is greater than 0. So for what values of y does it hold? So for example, I'll give you an example, it will be very easy. Say x is equal to 5. So for what values of y does this equation hold?
Minus and plus 5.
Very good. So you get this. So you duplicate your curve whenever you have mod across y or square across y. What do? Duplicate across x-axis. Similarly, you duplicate across y axis if you have mod across x, right?
Yes, sir.
Is this a function? Is this a function? Mod y equal to x?
No, sir.
Correct. For a particular value of x, there are two y's, right? So you can see. So if you feed 5, your machine will feed me 5 comma minus 5. I don't want that. Now, this is your homework. I'll do this one for you. Or rather, I'll give this one as homework. I'll do that one for you. Okay. Mod of x plus mod of y is 1. So let's take x comma y greater than 0. So in that case, x plus y is equal to 1. Right?
Yes.
Whenever there is mod, you need to consider only one thing. You just listen to this very carefully. It will become a cakewalk. So x plus y equal to 1 is this line. 1 and 1. I don't need to explain this thing. This is class 10 mathematics.
Yes.
For x comma y greater than 0. I'm only plotting for x comma y greater than 0. Now, if I put a mod across x, where do I duplicate it across? Just now I told
Y-axis.
Y-axis.
y-axis. Very good. Now I put a mod on y. Where do I duplicate it?
X-axis.
So you get a square. Right?
Yes, sir.
Good. So we have almost done there's only one more plot left. We'll then go to composition and finish the session today. I think we'll not be able to cover inverses today. We'll do it maybe next day before we start others. See. So what was the thing? So let's see. This is mod x plus mod y equal to 1. Did you get a square?
Yes, sir.
This is showing inconsistent things. Now you will see properly. It's between 1 and 1, right? It's a square.
Yes.
So x square plus y square, is this a function? Is this x mod y?
No, sir.
Correct. This one I will tell you is a circle. You will have to find out. Let's take a difficult case. I'll give you this equation. X minus a square plus, let's take a case, x minus 5 square and y plus 7 square. This is your, say, 3 square. You do this, I think you'll be able to find it out. And you will tell me next day, what is this? What did you get? Once you plot, you have Desmos at your disposal. You can download it from the App Store and see, Play Store. You'll be able to see. It will be very important, very nice, well-known equation you will get. The last thing is scaling. For example, sin x, I think if you are not familiar with the sine curve, you can ask me. Or I'll assume you know that curve. Let's take sine of x. If anyone does not know. Yeah, Hedvi, I know you can, it's correct, whatever you said, but I want you to use my way of plotting functions, plotting relations, and then so let's do this sine. If anyone is not aware of the sine curve, you can ask me. So anyways, I'll draw the sine curve for you. It's a periodic function. That means f of x plus 2 pi is f of x. In this case, periodic over 2 pi, right? You can see every 2 pi the curve repeats itself, right?
Yes.
This is called a periodic function. All trigonometric functions are periodic. So we'll do inverse function next time. So there, because anyways you'll have in trigonometric functions next class. So we'll do inverse functions next time before going to limits. That will be the best. So, but composition I want to do today, at least into one question, and then we can revise next class and before going to limits. So this one is the curve. So now what I do is, this is 0 to 2 pi. I make this function sine of f of 3 pi x. So what will happen now? Is the frequency increased or decreased? I know these are heavy terms, but do you think this curve will shrink or go far away? So I'll give you an example. For sine x, what happens? It is 0 at 0, 0 at 2 pi, 0 at pi, 1 at pi by 2, and minus 1 at 3 pi by 2, right? So now what I do is, I make it 3 pi x. So what will happen? So if I put the value of 1 by 3, so what values will I get? F of, if x is equal to 1 by 3, I will get f of pi, right?
Yes, sir.
Very good. Next, if I put 2 by 3, x is equal to 2 by 3, I will get f of x,
2 pi.
f of 2 pi. So that is a completing one curve, right? So you're completing 0 to 2 pi in 0 to 2 by 3. 2 pi is 6.28 and this is your 0.67, right?
Yes, sir.
So what you're doing, shrinking or extending? Whenever you have any factor multiplied to x, you shrink the curve. What happens is, you shrink the curve this way. So this is, again, if you have a doubt, you ask. This is 1 by 3, you have pi, this is 2 by 3, right? Is it correct or not correct? And then I recenter. What will I recenter? So this is say g of x. I'll make it g of x plus pi by 6, right? So at 0, it's sine pi by 6. What is sine pi by 6? 30 degree?
1 by 2.
Correct. So half. So you have something like this. You can find out the points. So it should be, so you can solve for it, no problem. So let's solve for it. 3 pi x. I'm solving for this point. What should I write for that point of x? Plus pi by 6 is equal to 2 pi, right? So I have 3 pi x is equal to 11 pi by 10 pi by 6, or you have 5 pi by 8, 5 pi by 6. Pi cancels. X is equal to
5 by 9.
5 by 9. Right, thanks. So you put 5 by 9 here, you'll get 2 pi. Yeah, Rohit, go ahead. I think they made some mistake, is it? 5 by 9 is smaller, so five by 9 is half, it's 0.67. Okay, it's correct. So 2 by 3 will be somewhere here. Good. So somebody had a raised hand, go ahead. Yeah, tell me. So let's list down the points that we have seen for your reference. First, transformation rules. and don't learn these rules. You derive it every time you plot. So I did not learn it, I did it today only. Again I found out the rules. So one is recenter. When you have y minus a equal to f of x minus b. Sorry. Right. So what will it recenter to? Your coordinate recenters to this, right? A comma b. I hear nobody speaking anymore. Recenter is 1 point. Another scaling that we did is reflection over x axis. When is it done? So mod x is equal to some function of x, y squared, y to the power 2n is some function of x. So if you have some curve like this, you would reciprocate on the x axis. C, reflect over y. When you put mod x, x square, so on, even pass. What else did we do? Shifting done, reflection done. So first question we did shifting and reflection. Second question we did reflection. Third question we did was rescaling. So f of ax. So if your function is between say a and b, say x1 and x2, what will your function become between? It will become between x1 by a and x2 by a. So you will shrink the functions. Right. So you shrink, or if it is more than 1 you shrink, less than 1 you enlarge. So once the sin x function was done, I think a few people have a doubt. You can ask the doubts before I go on to this question. This is the last question that we'll do. Or maybe I'll do the easier one. We'll do the composition difficult this question next day. So I see no one having any doubts, so let's do composition of functions. So you have a function A, you have a function B, set A, set B, sorry for that, and you have set C. Go ahead. So this is defined as, G is defined as between B and C. This is defined between F and B. This is nothing but f of G. So the only condition that needs to hold is that the range set of f must be a subset of B prime, must be a subset of the domain set of f, whatever the domain of f, right? So I think I've drawn this wrongly. This is G and this is f. So f occurs later after G, so you'll put x like this, so x will pass through G first and then go to f. So this is something like this. You have a machine, this is the f machine, this goes to the G machine, then goes out as f of G of x, also written as this way. So doubts? Let's see. We'll do this question, it will become clear. I have two questions on this domain thing. So a function f has domain -5 to 7. So f is capable of mapping from, so this is the sets. Can anyone tell me, help me out? What is the B dash set? minus 5 to 7, right? And you're mapping this using f, and from set A you're mapping through G. So you need to find the domain of f of G. What is the domain of f of G? How will I do it? Any idea? So any people who were, yeah, somebody wanted to comment.
G of x.
Correct, G of x. So f of G of x is nothing but, in layman's term, this is nothing but this. So you pass the function through G and then pass the entire thing to f. This is what is f of G meaning. So your f's domain is minus 5 to 7. So what should G's range be? This is your minus 5 to 7. So G's range should be inside this, right? If you have anything outside minus 5 to 7, will f be able to plot it?
No.
This is the most clear thing you need to understand. This will be very useful. So see, your range of G has to be a subset of the domain of f, right? If you have some values in G that are outside f's domain, can f do that? Others?
No.
Tanushree, I know you understood. Anyone else? So this will become clear. So tell me, so this G function should output values between any set that is a subset of minus 5 to 5, right? Minus 5 to 7. Is that clear? Because f's domain is minus 5 to 7, right? Okay.
Sir, my question is why it should be the subset? Why not equals to minus
It
5
can
to
be
7?
equal, no problem. Subset equal to is also a proper subset, right? Obrojyoti?
Yes, sir.
Yeah. So a subset means, I'm just generalizing. It cannot be a superset, that's what I mean. Or it cannot be exclusive, they cannot have non-overlapping data points. Is that clear?
Yes, sir.
Good. So now tell me, can g of x give you values between minus 5 and 7? Minus 5 and 0? Can it give? It's 2x plus 5.
So g of x cannot give negative values.
Very good. So this is does not belong. So only condition we need to check is g of x is less than this condition, right? That's it. G of x is always greater than 0, then you don't need to check. So but g of x must be less than 7. Right? Because any values greater than 7 will not be taken as by function f. So now I request you to solve this question now. So what will we do? We have already done a question like this, 2x plus 5 is less than 7. This is the solution to this. How will I do it? Again, we have already done this in the first part. I think that time Prarthi or Tanushree answered. Now someone else. What should I do? What should be case 1? And what should be case 2?
2x plus 5 equals to 7.
Equal to 7? No, it's a modulus function, right? So in case of negative values, you would have less than values. So 2x plus 5 less than 0 is 1, and 2x plus 5 greater than 0 is another case.
Yes, sir.
Always when you have mod values, you take these two cases, right? So this is between x less than minus 5 by 2 and this is x greater than equal to minus 5 by 2. Clear?
Yes, sir.
I'm doing it again. Now someone else will tell me what will be mod of 2x plus 5 in this case. What will it be when it is less than 5 minus 5 by 2? Just bear with me for 5 minutes now, then we'll be breaking today's session. It may be a bit. Okay. Is it why is no one answering? We already did it, right? We did it here. Where is the thing? This is the question we already did. Exactly similar question. If this modulus value is less than 0, what will happen? Go ahead.
Minus 62 is the answer.
Yes, that is true, but I just want this step. So otherwise I could have done it. I think that is the answer. So this will be minus 2x minus 5, right? Manish? I don't know what is your name. M Pandey. Sorry. Can you introduce yourself?
Sir, M. Pandey.
Yeah, your name.
Mahamrityunjay Pandey, sir.
Okay. So I'm just telling you. So this is correct, right? Minus 2x minus 5. Then does anyone have any doubt regarding that? So this is less than 0, so I put a minus sign to make it positive. And that is less than 7. Which means x is greater than or equal to minus 6. So what would be the intersection of these two sets? X is between minus infinity to, sorry for that, it will be between greater than minus 6, less than, so it's greater than minus 6 and less than 2.5. So this is this region.
Minus 6 comma minus 5 by 2.
Right, both will be included. Now the next part. Tell me, what should I write?
Greater than minus 5 by 2 and 2x plus 5 will be
Yeah,
less than equal
to 7.
to 0. 7.
Yeah, the equation is 7, so it's 7. So whenever you have a mod, you either put negative or positive. Yeah, go ahead, Mohammed, Mr. Pandey.
2x plus 5 is less than or equal to 7.
Yeah, so it's less than minus 1. So this means x is between minus 5 to by 2 to 1. Right? Anyone has a doubt here? And then we take the union of these two, so it becomes x belongs to minus 6 comma minus 1 or plus 1. So I think you told plus 2, so here we must have done some calculation error. Or did I do some calculation errors? Plus?
Sir, error.
Oh yeah. Maybe a small error, that's not a problem. So it's minus 6 to 1. This is how you define functions. So I'll give you a small exercise and we'll do it next day. You try this. I'll give you the answer as well. Answer is domain is 1 to e. Just to be sure all of you know this. This is your e to the power x graph. I'll show, and this is log x and e to the power x graph I'll show now. And range is, I shouldn't talk about this now, leave it. So I need to introduce sine inverse functions. Leave it. Better is, I would tell you to try this function. I would do it next day, this exercise, this composition of functions. This one is I would tell you to try. If more than few people would not be able to answer, I would do it in the next day. It's a very interesting one. Then you can do it on Desmos and see if your graph is matching with this. I would have done it today, but there was lack of time. we couldn't do it. But anyways, the first day we understood what functions are, ranges, domains, learned how to plot. I hope I made you understood. Do a lot of practice, and I think this question 6 will give you a lot of more idea about composition of functions. Try to plot. I'll give you a hint. Plot f of x, and then do f of x. F of x is nothing but this. F of x is 1 plus, you will get this note, you don't need to even note it down. As I told you, everywhere there is x, you just put f of x, because it's f of x. So f of x is the variable here. So you'll have f of x between 0 and 2, just replace. This is the hint. I'll tell you to draw this curve and so on. So do any one of you have any general doubts which you think we couldn't understand, or was
Sir, in the last problem we took union. In what cases should we take intersection, and in what cases should we take union?
I answered this question, you were not there, right? So
Yes.
if you divide into cases, these are disjoint cases, right? This is one disjoint case, and this is a disjoint case where x is greater than minus 2. This is greater than this value, this is less than some value. So you get, for this case you get a solution, for this case you get a solution. Both the solutions are correct.
Yes, sir.
So what will you take? Both the sets are correct, so you will take a union, right?
Yes, sir.
Now for case 1, this you have assumed to be true, and you got the solution to be greater than minus 6. So both these conditions must hold, right? So in this case you will be taking an intersection. When in a case you get another solution, you have already considered a particular range of x for that, and
That means within a case we should take intersections, and
Precisely.
among cases we should take union.
yes, precisely. Why do you need to take intersection within cases? I'll tell you to think about it, because both these two conditions must hold for this condition, for this case to hold true, right? That's why you need to, for both condition must hold. I drew this Venn diagram here. A and B must exist in the intersection. That's why. So in a case you take intersection, in multiple cases you take a union. That's the crux of it. So yeah, so I still have a raised hand. You can go ahead and ask before I stop the session today. Mr. Mahamrityunjay, do you have a question?
Oh, sir, thank you.
Yeah, don't. I'll request you not to call me sir. So I'm not an old person.
Sir, I will learn lots of things today,
Yeah, hopefully,
especially about graphs.
especially, I hope it will be a learning experience. I would try to cover as much as possible. I'll tell you people to revise and practice, so that everything that I covered today is clear the next time. So thank you.
Okay, sir. Graph was very good.
Yeah, you try plotting this this combination. You can try multiple graph translation problems yourself and try out. There's a lot of problems available on the internet. So anyways,
Okay, sir.
and Desmos is very useful. And Tanushri, go
Yes,
ahead.
sir.
So once can you please share the links of the both YouTube and the
Thank you for reminding. Yeah. So this is this channel you keep subscribed, so you don't need to, or at least keep the link to my channel fixed, so you don't need to worry about that. And this Google Drive link you keep saved in your system. You update things on this same Google Drive link. Okay. Okay, right, Tanushri? Did you get it? All of you?
Yes, sir.
Go ahead. Okay. You keep these two ready with you all, and then the one is the YouTube link. You can see the videos where things you didn't understand, or comment on things which if you want me to clarify. And the drive link would be fixed. I would tell you keep it saved in some place so that you don't forget. Okay. Nice. It was a nice experience. We'll meet next week in the same time. Bye.